All right, so I have tested 21 out of 22 of the LiBCM PCBs that I've just assembled over the last few days. And I'm gonna record the final test here. I'm sure I've done a video on this tester before, but whatever. So yeah, I've spent the last few days building more of these boards. We've had people waiting for a little while now. I think the oldest person waiting is from the end of July. So it is February, almost March. So that's a little bit. So obviously we need to get some units out. At this point I have 31 Fomaco pre-orders. And this is a batch of 22. And I also have a few people who are waiting on the 5Ah G3 kits as well. Sorry. I got busy last fall on this Fomaco stuff and still haven't shipped it. But that's what this batch is for. This is one of the steps. I sat down last Thursday and decided, you know, I need to do a lot of things that I don't know a bunch about before I can release the open beta, you know, for the whole project. But then I also realized that, you know, the Fomaco and 5Ah G3 are going to be running the same firmware. It's weird to exit open beta on one of those, but then not on the other, because you know, the Fomaco has, well, I've been the only one testing it for about 6 months now, I guess. So anyway, because I have a lot more expertise in building hardware and designing hardware, and a lot less expertise in firmware, I know what it's going to take to ship Fomaco. I don't know what it's going to take to exit open beta. That's the gist of it there. So anyway, I want to get these out. Not that I need rationale for it. I want to get these out there so that we can have Fomaco crew participating as well. And, you know, word of warning to the Fomaco crew, the 5Ah G3 crew, some of them have been using beta for over a year. Some of the alpha testers are certainly past a year and a half at this point. So if you're not comfortable with beta, this might not be the product for you right now. So anyway, we got all of our connectors hooked up, except that we forgot the temp sensors. And I'm going here off screen and open up the debug window here. So on the first units that I shipped, the first 5 to the alpha crew, I didn't have this tester at that point, so I literally had to stick each one of these PCBs in my car and drive it around. And if it didn't work, I had no troubleshooting other than just, oh, you know, I got this, it's probably that. But now, of course, I have this new hotness tester, and you know, this tester might look really piecemeal. I've seen much worse in production stuff, you know, in actual companies, not people doing stuff in their garage. So anyway, all we do now is we push this button, and the only thing I have to do is make sure this light blinks, which it does. And so that is 22. I have 22 of the boards, each of which has more than 600, I think close to 700 parts working. I mean, we're talking, I don't do math well, but 14,000 parts properly placed and all working 100%. That's wild. So this is not the last test that I do, but it's certainly the most thorough test that I do. And the test just takes that long, you know. And a lot of it is just waiting here for me to make sure this is blinking. And it does all the other tests now. Tests all the cells, everything. It tests everything on the board, which is really, really awesome. That's not 100% true. The only thing it doesn't test is that the actual resistors actually are discharging. It's very difficult to do that. So what I use a thermal camera. I know I've talked about that before. So I just literally sit here with a thermal imager and it just alternates to where all the odd cells are on and then all of the even cells are on. Anyway, that's 22 out of 22 cells. So we'll go ahead and disconnect this. So I'm super pleased about that. Before we got to this state, I actually visually inspected the board. I do that twice. So I visually inspect the board before it goes through reflow, because it's much easier to rework parts before they're soldered in place. Even with tweezers like this, these rework tweezers are fast, but certainly before the solder has been reflowed, and you can actually just sit there and move all the parts. So what that means is I visually inspect these 600 plus parts. I think it's 680 parts. It's just SMT, so all the through-hole stuff, that has to be inspected too. So anyway, there's a lot of inspection. I've inspected all these parts by visual twice now. Now, in a production high volume thing, you would actually have a camera system that would take this, and then it has known references on what a good and a bad part is. I don't have that, obviously. To do that for in your garage would be less difficult than it was 10, 15 years ago. I mean, it's certainly just you need a computer and software, but you also have to program it. And last I looked, there was nothing free that would do that. I'm sure there is now. But anyway, honestly, it doesn't take me that long. I think I probably spend a total of 15 minutes on every board. Now, of course, with a computer, it would take seconds. But then you might also spend hours and hours and hours programming it. What's a good placement? What's a bad placement? So that is this board. And so the last thing that we do is we make sure that this AC cord is kind of folding over properly, just so it doesn't get strain on it. I know that's out of frame, and then we stick a sticker on here so that I know this is passed, or at least at some point it worked. And then we have two other tests we do. One is the thermal test that I mentioned, and the other test is just to test the fans, because everything is populated electronically on this board at this point, except for the fans. Just because of the way we test that circuitry, the fans can't be installed. So yeah, that is 22 new LiBCMs. I've now built 100 of the production boards. I built 10 of the pre-production boards. Yeah, so let's talk about two other things. One is the daughter board, the LiBCM daughter board. This will not ship Rev A if you have the 1500 watt charger. I've made some changes to the right side, just things I didn't like. Nothing safety wise, but just things I didn't like. But if you are not getting the 1500 watt grid charger and you are wanting this daughter board, the 1500 watt grid charger is the entire right side of the board, everything I'm covering with my hand. So then, just having the left side populated, what does this give you? It gives you the storage so that you can go back and look at a month's worth of driving data. It gives you this nicer connector to the LI control PCB. It gives you the tachometer if you wanted tachometer fans. Again, I'm not 100% sure that's going to stick around. It gives you push button things. So you can basically put a button on here that if you're logging data and you have some event happen, you get a P code or you get some weird herky-jerky behavior, you can push the button and it'll just log it in the data. Here's where you're pushing the button. It makes it easier to find the data later. And then it also gives you a nicer header for the heater, for the 5 amp hour G3 heater. Anyway, I have 30 of these, Rev A, and of course it'll go to Rev B. These are so cheap that it doesn't matter that I have 30 of them, and I don't throw these PCBs away when I end up using them. PCBs are so useful for so many things. I don't think I've ever thrown a PCB I've ordered out because I just use them, or if I have thrown them out, it's because boy, I used them hard. Next up is LI control. This one has some changes. This will not ship Rev A either. Honestly, like I've shipped a lot of boards Rev A. When you have a design review team. This one I actually made a pretty elementary, stupid mistake. I hooked the drain and source on all the PFETs backwards, so they're flipped, which basically means that when it's off, it's got the 0.7 volt diode drop instead of a hard open, and then when you turn it on, you go down to a 0 volt drop. So anyway, that's a stupid error, and in trying to fix it, because all the parts are SMT'd on the bottom, when you look on the computer program, the KiCad program you use, the parts are actually mirrored, and of course I didn't remember that when I was reworking it, so I actually reworked them wrong again, and so I now have it correct. So the correct way is you flip the PFET over and you rotate it 45 degrees or whatever. Obviously that's not going to go into production. I haven't actually put this in the car yet because I just actually got the connectors for it today, or actually Saturday, but I just opened the box today. So here's one of the new connectors. So this is the potentiometer, the one that I've said in the past was, you know, more than $100. I bought 50 of these, and I think they only ended up being only $62 or $66 a piece when you buy a bunch of them. It's a different switch than I was using before. It has a different texture, and of course it's not gray, and I lament the fact that it's not gray, but that switch was discontinued. And there was like one left in stock, and I was like, what's the point? So it's going to be black, whatever, it doesn't matter. It'll be black instead of gray. The gray just matched the interior perfectly. And then it also misses a couple of the textured surfaces that were on here. And I like those, but you know, having this knob is plenty fine. I mean, that's ultimately how I drive it. The one I have now has the same knob here. It just had a nice textured, kind of a knurled finish, whereas this is a smooth finish. It doesn't ultimately matter. I did change the connector on the back because the connector this comes with is both, it comes straight off the PCB because the PCB's here, but it's a right angle when you look at the connector. And this right angle runs into the emergency brake lever, because that's where I install it, and it's probably where I'll recommend you install it. So I had to change this connector anyway. And then also the connector on this one's crazy to me. It doesn't have any shroud, nor does it have any latch, and so the cable can actually fall off. So anyway, I desoldered that, and I soldered this locking 4-wall shrouded, retained connector on, and it's going to be real nice. So you know, this will install, and then the other two switches, I don't have them here right now. And then all of those will have an Ethernet cable, or you know, RJ45 cable. Pardon that I will always call this an Ethernet cable. I know it's an RJ45. And this will plug in, and then on the other end it will have the 8 connectors. So you will plug this connector in, the other ones have some spade terminals that you put on instead. So that'll be really nice. And then of course, if you don't want to put these controls in, you know, near the console by the emergency brake, then you know, you can make the Ethernet cable as long as you want if you want to put it somewhere else. And of course I'll make it, if you want it 10 feet, 15 feet, a mile long or whatever. At a mile, I can't guarantee the signal integrity. Anyway, so LI control, I haven't put it in the car yet, but I will because I just got the parts. I just opened that box today. As far as I can tell, this is going to work just fine, you know, with the PFETs here, flipped the correct way. Yeah, I'm still not 100% sold on this RJ45 connector. I think I might switch all 3 over to this style connector. It's the 4-wall shrouded, you know, locking tab connector. I don't know, on the fence about it. The RJ45 is neat just because the cable is extremely cheap. It's extremely available. And anyway, other things, I realized that this plugs into with LiBCM, you know, including the 5 volts and ground. And so this actually never turns off right now. Whoops. So that'll be changed in the next revision. And then I think I'm also going to put both the reset, instead of the 5 volt here, because I don't want the 5 volt pin, I think I'm also going to put the reset and chip select line on here so that I can program this more easily. That's kind of an implementation thing that doesn't really matter to the end customer. But yeah, hopefully we get this in the car tomorrow. And yeah, so that's basically it. You know, right now I'm going to try and ship these Fomaco kits soon. I need still, you know, I've just finished the PCBs, and so I still need to fold the polycarbonate covers, and then I need to make all the wire harnesses. So yeah, no timeline on it, but it is going to be what I'm working on. And you know, the open beta customers, you know, if you can just tolerate this longer, I mean, I would rather the Fomaco customers who have been waiting for 6-7 months get these Fomaco kits and then participate in the beta as well. So anyway, there's only one of me, and this is kind of what I'm wanting to be working on right now. We will eventually leave open beta. Don't know when that's going to happen. I probably am just not going to give timelines anymore at this point. This is a passion project, and I don't have a manager. You know, I'm not that old, but I've worked long enough for other people, even as a consultant. I don't need a manager right now telling me when and what I need to work on. This is a passion project. I'm going to work on whatever I want to work on. Someday we'll leave open beta. That's the way it is. If you ever need a reminder on when we're going to exit open beta, it's when it's ready. It's on the back of the daughter board PCB whenever that starts shipping. So, and of course I mean that all in a humorous aspect, but you know, it is a question I get a lot, and I don't have an answer to it, and I don't really want to have an answer to it either. It's a beta. Someday it won't be. As always, thanks for watching, and yeah, no real point to this video other than just to show you what I've been working on the last several days.